Okay, we're continuing from this book here, Prevent and Reverse Sleep Problems by me, Pete Rogers. We're at the level of this painting, page 66, the Limbourg brothers. And the point of the painting is, all through recorded history up until the last 100 years, humans did stuff outside in the daytime and then they slept at night when it was dark. So we were very much tuned in to the sun for our circadian rhythms. Nowadays we have all the artificial electrical light, and especially the blue lights at night, that mess up our circadian rhythms. We do best when we get a little sunshine right first thing in the morning, okay? And we perceive the sky blue as daytime. So that in particular affects us, okay? I'm just going to explain the pictures. That's sort of the highlight of the book. As far as our eyes are concerned, the peripheral vision comes from the rods and the cones. And they're really sort of low concentration of them, such that you just sense abnormal motion. Then you turn your head and look with both eyes, binocular vision, to figure out what the thing is. In the center of our eyes is the macula, the fovea, with concentrated amount of cones. Those are the color photoreceptors. And so we can see by their concentration more precisely, more fine resolution. Okay, then there's a third type of photoreceptor within the retina, and that is just intrinsically photoreceptive retinal ganglion cells, and those simply detect light or no light, or blue light, especially if it comes from above. It hits the bottom of the retina, and that says daytime. Blue light from above means daytime, okay? A little bit of red light coming from below can be fire, and that'll hit the top of the retina. So the worst at night is to have blue lights on your ceiling. So one of the things I do as soon as I'm done making my YouTube videos is I shut off all the overhead lights, and I have a little tiny lamp on the ground. The light comes into your eye, let's say the blue light in the daytime. It goes to the SCN, suprachiasmatic nucleus above the optic chiasm. That's the clock for the entire body. Then that sends a message to the pineal gland if it's daytime, shuts off the pineal gland if it's nighttime, turns it on to make melatonin. At night, that melatonin goes from the pineal gland all throughout the body, and it has a protective effect upon mitochondria. In the daytime, the melatonin is made in the mitochondria themselves. It's important that the body can synchronize itself with the circadian clock. It all works better that way. I'm going to show you a slide of the things that sunshine does that are beneficial to us. So first thing sunshine does, we all know, gives us a suntan. That comes from the ultraviolet light, short part of the spectrum. You can block that just with any shirt. That'll give you a suntan. Okay, too much of it will give you a sunburn. You also make vitamin D from the sun. All right, on the long wavelength part of the spectrum, you get red and infrared light, and that improves mitochondrial function. That goes into your mitochondria, and it gets them to fluidize. The gel-like component of the matrix becomes more liquefied. ATP synthase can spin faster, and you can make more ATP. Okay, what else? It'll also lower your blood glucose. Okay, it's going to cause vasodilation because it'll release systemic precursors of nitric oxide from your subcutaneous tissues. Those will open up your blood vessels, and that'll lower your blood glucose level, allowing more glucose uptake into your muscle cells to produce glycogen, for example. There's some researchers who suggest that sunshine is also increasing sulfation of the endothelial glycocalyx, meaning the lining of the arterial cells gets more negative charge, more sulfates, which means it increases its zeta potential, which is good. You want that. Helps prevent clotting, helps maintain the stability of the zeta potential. Most important time to get sunshine is in the morning to set your circadian rhythm, and also it has a more positive, stronger positive effect on your mitochondria. And again, it's the red light that does that, the red and the infrared light. Infrared just means near to red light. So the visible spectrum runs from like about violet to red, okay? Infrared is beyond what we can see, okay, longer wavelengths. Ultraviolet is beyond what we can see, shorter wavelengths, okay? All right, so here's showing the photodetector for red light. You put it behind the patient, and the red light goes all the way through the patient's body, even through their clothing. So it's got much better penetrating ability. That's why, you see the lawnmower guys, they can wear a sweatshirt, t-shirt, and it'll prevent them from getting a sunburn and a sombrero. But you're still going to get this red infrared light going through you. And that's why it's also good to go out even on a cloudy day. On a cloudy day, the same long wavelengths that can pass through your body, they can also pass through the clouds. So you still get that benefit for circadian rhythms and for your mitochondria. red light therapy, sometimes called photobiomodulation. Okay. One thing I wanted to make the point about was the 4 phases of water. There's 4 phases of water. Everybody knows liquid water, gas, water vapor, ice, solid, but there's a 4th phase, which is gel. And the way you know it's correct is that, think about it, you get a cut. You don't bleed water. You have blood or nothing, okay? If you take an egg right from underneath the chicken and you crack it, you're going to get gel. You don't get water. How come if we're 60% water and mammals in that ballpark, why not water comes out? Because most of it's in a gel form, okay? And that enables a cell to better compartmentalize things. Okay, so here's a mitochondria. And in the mitochondria, a lot of that fluid's in a gel phase, especially right next to an enzyme called ATP synthase. And when the sunlight comes in, it'll fluidize it, and that makes it softer, and so the ATP synthase can spin faster, make more ATP. This is just showing how mitochondria works. You basically have an outer membrane, OMM, outer mitochondrial membrane, and an inner membrane, inner mitochondrial membrane, some protein transports that transport electrons down until they get to complex 4. And that energy of them rolling down a hill like a snowball, the progressively stronger electron grabbers, is coupled to the pumping of protons into the intramembranous space between the outer and the inner membrane. And that gradient of concentrated proteins in the intramembranous space can be harvested to allow a proton to come back into the matrix, spinning ATP synthase and adding a phosphate to ADP, adenosine diphosphate, to become adenosine triphosphate, tri as in 3 phosphates. And the fluid around here is in a gel form at rest, but then it gets fluidized by the red infrared light, so you can make ATP energy faster. And so that's a big benefit. That sort of just shows you the gradients, negative 160 millivolts, the biggest gradient of anything in the whole human body. I think we're going to skip that slide. This is just showing you that, in a sense, what happens is the mitochondria is like an electron nuclear power plant. It splits the atom. It splits the hydrogen atom into its constituent protein and its electron. And again, the protons are pumped into intramembranous space, H plus, H plus, H plus, that's a proton, whereas the electrons are passed down through the inner mitochondrial membrane electron transport chain, which is like a snowball rolling down a hill. So anyways, I hope you found that helpful. That's it for today.